Hello, my name is Giovanni Galvin, and I'll be presenting Part C for the Newton's Law of Universal Gravitation. For my first slide, we have the original process of the original lab environment Millikan had. He worked in a quiet laboratory with controlled air and lighting to carefully observe tiny oil droplets. And the original lab equipment he used an atomizer, microscope, electric plates, and a voltmeter to study the behavior of charged droplets. In the original experimental procedure he had, step number one, he would spray tiny oil droplets into a chamber. For step number two, use electric plates to make droplets move up and down. And for step number three, measure the motion of droplets to calculate the charge of electrons. For original difficulties, he had initial hurdles. Measuring the tiny charge of a single electron was extremely difficult, and careful observation. For safety issues, he had working with high voltage electric plates could be risky if not handled carefully. And equipment issues, early microscopes and voltmeters were not very precise, making measurements challenging. And for information processing issues, he had calculating the exact charge of the electron required complex math and careful record keeping, which was time consuming. For original motivation, original goals for the scientist Millikan, he aimed to measure the exact charge of a single electron. This discovery was intentional, not accidental, and expected beneficiaries, scientists, educators, and future engineers expected to benefit by gaining a better understanding of atomic structure and electricity. For modern process, the modern lab environment today, experiments are done in advanced labs in controlled temperature, humidity, and computer-assisted monitoring to ensure precise measurements. Modern lab equipment uses digital microscopes, automated droplet generators, precise voltage controllers, and computer software for data collection. And for the third part, modern experimental procedures. You have 3 steps. Step number 1, generate tiny oil droplets or use, what am I talking about here? But for the modern experimental procedures, step number 1, generate tiny oil droplets or use stimulation software. Step number 2, apply controlled electric fields to move droplets. Step number 3, use computer to track droplet movement and calculate electron charge quickly and accurately. Modern differences, modern advancements. Experiments now use digital tools, precise instruments, and computer stimulations for faster, more accurate results. Have modern protections and safety. Labs have safety equipment, voltage controls, and strict protocols to prevent accidents. And they also have modern information gathering. Data is collected automatically using sensors, digital microscopes, and computers. And for the fourth part, they have modern information processing. Computers analyze the data quickly, reducing human errors and allowing detailed calculations. Future expectations of Millikan's research. Future goals for scientists. Scientists will continue studying electrons and light to develop better technology, faster computers, and new energy source. Potential benefits: more efficient solar panels and renewable energy sources, advanced electronics, and smaller and smarter devices. New materials for medicine, batteries, and nanotechnology. And for the last part, better understanding of quantum physics for the innovations.
How you doing? My name is Rubber Red. I'm in the Newton's Law of Universal Gravitation group project in physics. My group partners are Giovanni Galvin, Alicia Morris, Brianna Bitts, and this is Part C version of my project. First 2.1 Part C, original experimental process described. It's basically describing the original lab environments and things that went on in the laboratory and how things were kept and observed and different things that was done in the laboratory, cleanliness, amongst other things. Describe the original lab equipment was telescopes for observations, pendulums, weights, things of that manner. I describe our original experimental procedures. They had plenty of procedures with Newton, with the gravitational experiments. Newton studied gravity in the 1600s using data from astronomers like Kepler. He worked mostly in his study, not his lab. He used things like telescopes, pendulums, and the math was done by hand. He discovered the inverse square law, showing gravity weakens with distance. He did a lot of things with this. 2.2 Part C, difficulties, complications, explain the original difficulties. Initial hurdles was lack of precise data, instruments, limited early measurements of planetary motion. These were very early in the ages of science, so they didn't have the technology we have today. So it was big limitations, but it didn't stop them from getting us where we are here today. safety issues, equipment issues, information processing issues. They fought hard to get where they are, so we can have the information and progress in society like we have today. The original motivations for this experiment, origin goals: to understand the forces controlling planetary motion and tides on Earth, intentional or accidental discoveries, intentional Newton aimed to explain celestial and terrestrial motion with one universal law. It benefited astronomers, physicists, and navigators who relied on accurate predictions of celestial motion. Original benefits and discovery discussed 2.4 part C. Immediate benefits: unified motion of planets and falling bodies under one law. Advancements in classical mechanics, foundation of universal gravitation and motion, and other fields, astronomy and navigation accuracy. And in new fields, it inspired modern physics and calculus applications. Newton's law unified the motion of the planets and the falling objects. It helped predict orbits and eclipses accurately. His idea became the base of the modern physics and engineering. The modern experimental process described. The modern lab is with way more up-to-date technology, conducted in observations, universities, and space agencies using advanced instruments, modern equipment like different types of lasers, space telescopes, and satellites. Today we study using satellites and telescopes and computers. Modern labs include space agencies like NASA and observatories worldwide. Difference in modern approach. Modern advancements such as data precision improved with digital instruments and supercomputers. Modern protection safeties, automated systems reduce human exposure to physical hazards. Modern information gathering, collected via satellites and deep space probes, and things of that sort. Modern researchers use advanced technology and data systems. We gather information from satellites instead of ground tools. That's how they started. Modern benefits of discovery. Modern benefits: better understanding of celestial mechanics and orbital prediction. Other fields that benefited was astrophysics, aerospace engineering, GPS satellite navigation. Newton's law still supports today's technology. GPS satellites and space missions depend on gravity research, gravitational waves discoveries, and so on and so forth. Future expectations. Future goals: to unify gravity with quantum mechanics, detect the map and dark matter of gravitational effects. Future studies aim to connect with gravity with quantum mechanics. Scientists hope to learn more about dark matter and dark energy and things of that sort.
Original process of the Cavendish experiment was in Cavendish's estate in England. It took place in a quiet room to avoid external disturbances, and it was also enclosed in a wooden box. The lab equipment used was a torsion balance, large lead spheres, thin wire, a mirror and a scale, and an enclosed protected environment. Experimental procedures: so setting up the torsion balance itself, positioning the lead spheres, measuring angular deflection, repeat with sphere repositioning, and calculating gravitational constant. Some initial hurdles with the Cavendish experiment was environmental interference. Air currents and vibrations and temperature fluctuations disturbed the apparatus, so that's why he had to set it up and isolate it in an enclosed wooden box. Safety issues was lead exposure. Some equipment issues that they had was measurement precisions. And information processing issues was he didn't have any digital tools to help him. Everything was done manually. So Cavendish's original goals was to measure Earth's density, not gravity itself. The people that benefited was future generations. It had a huge educational impact and, of course, an impact on the science community itself. So the benefits of Cavendish's discovery was measuring Earth's density. He also set the foundation for gravitational constant, and he did benefit other fields as well, such as astronomy and space exploration. So the modern process of Cavendish experiment is labs are temperature regulated and they are still isolated. Instead of using a wooden box to enclose it, they use a vacuum chamber. And experiments are monitored remotely now. Modern lab equipment that they use is a computerized torsion pendulum, tungsten wire, which is more durable, laser and photodiode systems, lead or steel spheres, so that's optional too. You have more options now available with that. Data acquisition software and vacuum chamber is optional. Modern experimental procedures are setting up the torsion balance, calibrating the system, measuring angular deflection, analyze data, and repeating and averaging. So there are some modern differences, especially with technology being so advanced now. So we do have high precision materials. The tungsten wire is more durable than the thin wire that they used to use. Laser-based measurement, which helps detect angular deflection with better accuracy. Vacuum chambers reduce air and thermal noise. And digital automation just enables, or not enables, it decreases human error. Modern protections and safety, so lead handling protocols, electrical safety standards, vibration isolated platforms, and remote monitoring. Modern information gathered is digital sensors, high-speed cameras, and environmental sensors. And modern information processing is the data acquisition software, statistical modeling, cloud-based storage, and machine learning, and more advanced labs. Some modern benefits is precise measurement of gravitational constant, improved understanding of fundamental forces, and enhanced experimental techniques. Fields that benefited from the Cavendish experiment is astrophysics and space exploration. And examples of technology spawned is the GPS, gravitational wave systems, or detectors, my apologies, and satellite navigation systems. Things that we can expect in the future due to the Cavendish experiment is gravitational wave background, so they'll be able to detect it, and potential benefits to come will just be new insights into the early developing stages of the universe.
For the original process, we're going to start with the lab environment. For the lab environment, Pierre worked in the Andes Mountains during the French geodesic mission in the 1730s. The area was high altitude with thin air, cold weather, and rough terrain. Observations were done outside and at night to measure star angles. For the lab equipment, he used quadrants and telescopes to measure star positions, also used measuring chains and rods for the triangulation on the ground. For the experimental procedures, he marked long triangles across land to find the length of 1 degree of the Earth's curves. He compared the equator measurement with data from France to test Newton's prediction. He also helped confirm that Earth is slightly flattened at the poles. For original difficulties, we're going to start with the initial hurdles. For the initial hurdles, he did travel to South America. He did travel to South America, which took months by ship, mule, and on foot. Worked at very high altitudes, causing sickness and slow movements. For safety issues, the team worked near cliffs, volcanoes, and unstable terrain. The weather was unpredictable, with storms, freezing air, and thin oxygen. For the equipment issues, I have that the instruments expanded or they even shrank from temperature changes. The thin air affected pendulum timing and measurements. For information processing issues, I have all calculations were done by hand with no computers, so many corrections had to be applied to avoid errors. Original motivation. For the original goals, the mission was created to test whether Newton's law of gravitation correctly predicted Earth's shape. Scientists wanted to know if Earth is slightly flattened at the poles, as Newton said. Whether or not it was intentional or accidental, I have here that the study was fully intentional. It was planned and funded by the French Academy for this exact purpose. Who benefit from this study is, well, for the benefit of the study, better knowledge of Earth's shape, improved maps, and sea navigation. It also helped build trust in Newton's universal law of gravitation. Original benefits. The immediate benefits included the measurements strongly supported Newton's prediction that Earth is flattened at the poles. This gave real-world evidence in favor of Newton's law of gravitation. For the advancements, map making became more accurate for travel and navigation. Scientists even gained a correct model of Earth's shape to use in future work. For the modern lab environment, gravity is now studied with satellites and digital instruments. Work is done in research labs and space agencies. For the equipment, satellites such as GRACE measure gravity changes from space. Modern tools also include gravimeters, GPS, and computer models. For the procedures, I have computers process large amounts of gravity data. Scientists also compare gravity maps over time to study how Earth's mass moves. For modern differences, I have here, I have the advancements, protection, safety, information gathering, information processing. For the advancements, measurements today are millions of times more precise than in Pierre's time. For the safety, scientists no longer need to climb mountains to collect gravity data. Most gravity work is done remotely or with controlled instruments. For the gathering of the data, it is now collected automatically by satellites and sensors worldwide. Computers also apply corrections and produce global gravity maps. Modern benefits. Gravity data helps track melting ice sheets, groundwater loss, and sea level changes. Other benefits would include, or other fields that benefited from this would have been engineers because they use gravity data for bridges, tunnels, and research surveys. Space agencies also benefited because they use gravity studies to understand the planets and moons. The technology that was spawned from this would have been satellite navigation and Earth monitoring systems, which depend on gravity modeling. Future expectations. So for future goal for scientists, they would create sharper gravity maps that can detect even smaller changes over time. They would also combine gravity with other data to study Earth's interior more accurately. Potential benefits would include better prediction of environmental change and natural hazards, also stronger understanding of gravity to support space missions.